In this video, we will create how to make a drawing of the universal coupling assembly. So if you didn't check out the previous videos, how the assembly is created and how the individual parts is created, you just check it out the description. The link is given in the description. Now let's create let's create the drawing of this universal coupling assembly. Okay. So for that, click on this plus symbol and create the drawing. So you select the ISO A4 format. So if you're not able to find it, go to the Onshape and go to ISO and select ISO A4 and give OK. Now let's try to create the assembly drawing first, then we will go on to the part drawings, individual part drawings. Okay, so let's try to insert the assembly here. So the front view of the assembly came, the top view, the side view, and the isometric view. So for creating the isometric view, click on the front view and just move diagonally so that you will get the isometric view. So if you want to show the isometric view as a shaded view, you can just select show bar hide and give show shaded view so that you can able to see it on the shaded portion. Okay. So now let's try to insert the bill of materials table here. So for that, go under the node and select the BOM table. So here at the top right corner, I'm going to attach it. So let's try to adjust these parts. Okay. So now let's try to provide the call out for this, because we need to know which one is fork, which one is shaft. So we have to represent it to our customer so that he can able to understand it in a better way. If a new parts are created, generally the people may not be familiar. So let's try to create the callouts. So under the same, you just go for the callout. So here you can see this one is a shaft. This one is your fork. And this one is your pin. And this one is your collar. And this is a taper pin. So key might not be visible. So you can able to create a key from a section, or you can take it from here. Sorry, I not selected properly. So you can see it over here. This one. Okay. So on this place. So from any view of the drawing, you can select the call out. You can see it over here. So now we have created the assembly drawing. Okay, now let's try to create the individual component drawings. So for that, let me add a sheet. Okay, so you can give a sheet. Before that, you try to give the title over here as universal coupling. Okay, so let's try to add a sheet. So in this sheet, we are going to make the individual components. So let us try to insert the component over here. So let's try to insert. First is the fork. So defaultly the sizes will come over here. So if you want to increase the size, you can increase it if you want. Okay, so let me increase the size to 1:2. So a front view, instead of front view, let me make the top view over here, so that I can make a cross section view on the front. So sectional view on the front. Okay, so let us try to make a section view, a horizontal section view, exactly passing through the center. Let's try to make it over here. Okay, so a top view first is created, then you go for the sectional front view. Suppose if you want the hatching lines to be with the instead of ISO, if you want to go for the ANSI, that is a continuous lines, you can go to the settings and change the drawing properties. The hatch pattern, you change it into ANSI, it will change. Okay, now this is the first part. Let's try to insert the second part. If you want the side view, you can insert it. So insert, so projected view. From here, let me go into the side view. Okay, now similarly, let's try to create for the other blocks. So insert view, go to insert. So let's create the central block. So central block. So first let's select the top view here. Then create the section view of it. So go to section view, make a horizontal section and select exactly on the center and make it over here. So you can able to get a sectional front view for the central block. Now let's try to insert the other parts. So insert, key, so this one and the cross section. So 2 views is enough. Let's try to insert the other part. Pin, collar and taper pin. So pin, let me insert it first. So here you can insert a pin. So front view and the top view we have inserted. Then insert view, insert. In that, let's try to represent the collar. So first front view, then top view. So here if you want to provide the cross section, so you just delete the front view and go for a sectional view. So you can get a sectional front view if you want. So here also if you want to make a sectional front view, you can make it. Okay, so that this view will be visible. Okay, let's try to make a section view exactly on the center. Let's try to do it. So you can see there is a hole here. The same hole is represented over here. Then insert, so taper pin, let's try to provide the size. Then insert, the last one is the shaft. Let us try to insert the shaft. So 2 views is enough. Okay, so now insert the different dimensions required for it. So you can insert different dimensions. Okay, so dimensions are, for example, if you take this shaft which is of diameter 55 and this is radius 15 and this hole is diameter 16 and this is radius 15, and from the center, so for example if you want to insert the center lines, you can able to insert it, 2-point center line between this one and this one. So you can insert center lines. So from the center line you can able to provide the dimensions. So let me try to adjust the space so that I may have enough space on the top. Okay, so dimension between this center and this end, it is going to be 18, and this gap, so between this center and this center, it's going to be 10. So you can keep it over here. And the same depth you can able to provide it. So depth of this one, it is 38. So here let me provide it as 38. And the keyway size, you know it, so let's not do that. So here let's try to make this diameter and this diameter, and the length between this two and the length between this two. Same over here, and the center distance between these two has to be provided. So for that, let's just try to move upwards. So in this, let's try to provide a center line over here. So a 2-point center line. Then provide the dimension between this center and this center. It is going to be 18. I think that's all required for this. So let's have this length as 40, and this size is 8 cross 8. So from here to here it is 8. So here we need to provide the slope. So you have to provide the slope as a node. So let's try to draw a node here. So here let's try to write it as slope 1:100. So let's confirm it. So this one you have to add a leader to this one. Okay. So this slope is 1:100. Then let's try to go to the other parts. So here let's try to insert the dimensions. So dimension between this end and this end, it's 100. So here it is given as 100. And here if you want to show the hidden lines, you can show it by enabling it on show bar height, so that you can able to enable the hidden lines over here. Okay, so you can see it's the taper hole is available over here. Okay, now let's indicate the dimensions of the diameter. So diameter is 25 and this diameter is 16. Okay. Similarly here, let's try to indicate a center line between the two edges, between these two. Let's try to extend this line. Okay. And the total distance, we know that it's 12, and between the center and one end it is 6, and this diameter it is 25 and this diameter is 60. Okay, so if you want to insert the hole here, you can, if you want to represent it as hidden lines, you can represent it. So here is a hidden line, and if you want to show the side view, you can show it. For example, let me move this part over here. So let me insert a side view here from this place. So here we are having it. So this one you mention it as hole for dia 3 taper pin. So let's make a note of this one. So hole for dia 3 mm. Okay, taper pin. So let's confirm it. Actually it is not a spelling mistake here. Taper pin. Okay. Now only we need to insert the dimensions for this too. So here let me insert the dimension for a slope. Okay, So for here, let me write down the slope as 1:100. So this one, and the diameter is 3. Okay. So let's give the dimension for this. It's a radius 15, and this one, the diameter is over here, and here you have to represent the keyway. So let's try to give it as a hidden line. So this one you have to represent it over here as a node. So that node, let me try to represent it with the keyway 8 cross 4. Okay. So if you don't have enough space, you just try to extend this. Okay. So we have inserted all the parts, components, drawing over here. So if you want to insert a special scale, for example, if this one, the diameter is too small, it doesn't have the better visibility. So here you can change the scale size if you want as 1:1. So automatically the scale will be adjusted. So you can see it over here. So here you can able to get a better visibility. So only for this one, the scale size is 1:1. For all other remaining three, you can see here the scale is 1:2. Okay. So now we have completed all our drawings. So here if you want to show the hidden lines, you can show it over here. You can see it. So the hidden lines for your keyway and the shaft. Okay, so the shaft hole, both are given as a hidden lines here. Okay, I think we have completed all the component drawings as well as assembly drawing here. So both we have completed. Thanks for watching. We will see you in another video.